Now, in this lecture, we find out the radius of the semicircle. In the drawing, we have a semicircle, and also we know that line segment PA equals to 6 units in its length, and line segment PA is also tangent to the semicircle at point A. We also know that line segment PQ equals to 4 units in its length, and also line segment PS cuts the semicircle at points Q and S. We also know that QS equals to QC. This is angle PAB that is equal to 90 degrees. This angle SQC also equals to 90 degrees in its size. Again, our mission is to find out the radius of this semicircle. So first of all, I present to you a new rule, and we will implement the new rule in our drawing. The new rule is rule number 10. According to rule number 10, in any circle, if AB is any chord in the circle and PT is a tangent to the circle, then the following equation is true, that PT square equals to PA times PB. So here we have tangent PT, that is tangent to this circle at point T, and we also have line segment PB that cuts the circle at points A and B, and this way we created a chord AB. So in this drawing, the following equation is true, that PT square equals to PA times PB. Again, PT square equals to PA times PB. You can actually implement rule number 10 in our drawing. Why? Because in our drawing, if we focus on point P, from point P we have tangent PA to the semicircle. Tangent PA is tangent to this semicircle at point A, and we also have here line segment PS that cuts the circle at points Q and S. For that reason, we can actually implement here rule number 10. And according to rule number 10, PA square equals to PQ times PS. Repeat again. If you focus on point P in our drawing, you can actually implement here rule number 10. According to rule number 10, PA square equals to PQ times PS. PA equals to 6 units in its length, therefore PA square is 6 squared, that is 36, and it is equals to PQ is 4 times PS. PS equals in total to 4 plus QS. Okay. So I actually found out that according to rule number 10, 36 equals to 4 times 4 plus QS. Here we divide this equation by 4, and we get that 36 over 4 is 9, so 9 equals to 4 plus QS. Here we subtract 4 from this equation, and we get that QS equals to 9 minus 4, that is 5. So QS equals to 5 units in its length. This line segment QS equals to 5 units. But according to what is given us the question, QS equals to QC, and QS is 5, therefore QC must be also equal to 5 units in its length. In the next step, we join points P and C together by a straight line. We'll focus on the lower side of the straight line PS at point Q. Again, we focus on the lower side of the straight line PS at point Q. According to rule number 3, the sum of the angles on the lower side of the straight line PS at point Q must be equal to 180 degrees. I'll repeat again quickly on rule number 3. According to rule number 3, the sum of the angles on one side of a straight line is equal to 180 degrees. So in the drawing we have the straight line AB. If we focus on the upper side of the straight line AB at point Q, here the sum of the angles must be equal to 180 degrees. So which angles we have at the upper side of AB at point Q? We have this angle alpha and this is angle beta. So according to this rule number 3, the sum of the angles on the upper side of the straight line AB at point Q must be equal to 180 degrees. That is to say, alpha plus beta must be equal to 180 degrees. Actually, we can implement rule number 3 in our drawing. Why? Because in our drawing, if we focus on the lower side of the straight line PS at point Q, here the sum of the angles must be equal to 180 degrees according to rule number 3. So which angles we have at the lower side of PS at point Q? We have this angle that is equal to 90 degrees plus the missing angle. In total, they must be equal to 180 degrees. Therefore, this missing angle must be equal to 90 degrees. So actually the missing angle here must be equal to 90 degrees according to rule number 3. Therefore, triangle PQC, this triangle PQC is a right triangle, so I will copy the right triangle PQC in a new page and we will implement on this right triangle PQC the Pythagoras theorem. By PT is abbreviation for Pythagoras theorem. So actually, this is the right triangle PQC that I got from the original drawing. Side PQ equals to 4 units according to what is given us in the question, and we just right now found out that QC equals to 5 units. So according to the Pythagoras theorem, this right triangle PQC, PC square, that is the square of the hypotenuse, must be equal to PQ square plus QC square. So PC square equals to PQ square. PQ is 4, therefore PQ square is 4 squared, that is 16, plus QC square. QC is 5, therefore QC square is 5 squared, that is 25. So in total, PC square equals to 16 plus 25, that is 41. So actually found out that PC square, that is the square of the hypotenuse of the rectangle PQC, is equals to 41 units, 41. PC square equals to 41. In the next step, I will copy the right triangle APC in a new page and we'll implement on this right triangle APC the Pythagoras theorem. Again, by PT is a version for Pythagoras theorem. We already found out that the square of the hypotenuse, that is to say PC square of this right triangle PC, is equals to 41. According to what is given us in the question, side PA of this triangle PAC equals to 6 units. We define the length of side AC as A. Here by PT is a version for Pythagoras theorem. So in this right triangle PAC, according to the Pythagoras theorem, PA square plus AC square equals to PC square. PC square is 41 and it is equals to AC square. AC is 8, therefore AC square is A square plus PA square. PA square is 6, PA is 6, therefore PA square is 6 squared, that is 36. In conclusion, we found out actually that 36 plus A square equals to 41. Here we subtract 36 from this equation, and finally we will get that A square equals to 41 minus 36 is 5. So A square equals to 5. Here we take a root out of this equation, and finally we will get that A equals to the square root of 5 units. A equals to the square root of 5 units. So we can write here that AC, that is A, according to our definition, is equals to the square root of 5 units. Okay, so in the next step we will find out the length of this line segment CB. Actually, it is given us the question that this is a semicircle, and therefore AB must be the diameter of the semicircle. So I write it down. AB is the diameter of the semicircle. So we will define the radius of this semicircle as x. So if the radius of the semicircle is x, it means that the diameter AB is 2x. So AB equals to 2x. AB equals to 2x. So what is the length of CB? From the drawing, it is very easy to see that CB equals to AB minus AC. So I write it down. CB equals to AB minus AC. That is to say CB equals to AB, that is the diameter of the semicircle, it is equals to 2x, here AB equals to 2x, minus AC. We have only found out that AC equals to A, and A equals to the square root of 5 units. So AC is square root of 5, so in total we actually found out that CB equals to 2x minus square root of 5 units. So we can write here that the length of this line segment CB equals to 2x minus square root of 5 units. In the next step, I will complete the semicircle to a circle. So we completed the semicircle to a circle, and then we will extend side QC by straight line until it touches the circle. And we will define the touching point of the extended side QC with this circle as point M. In the next step, I will present to you a new rule, and we will implement a new rule in our drawing. Because the new rule is rule number 11. Rule number 11 is about two chords that intersect with each other inside the circle. In the drawing we have chord AB that intersects with chord CD at point O. Point O is the intersection point between the two chords. Whenever two chords intersect with each other, then the following equation will be true. That AO times OB equals to CO times OD. Again, AO times OB equals to CO times OD. So we can actually implement rule number 11 in our drawing. Why? Because in our drawing we have chord AB that intersects with chord QM at point C. Again, chord AB intersects with chord QM at point C. Point C is the intersection point between the two chords. Therefore, we can actually implement here rule number 11. So I write it down. Now, drawing chord AB intersects with chord QM at point C. Repeat again. Now going, chord AB intersects with chord QM at point C. Therefore, according to rule number 11, we will get that AC times CB equals to QC times CM. Again, AC times CB equals to QC times CM. Here we will define the length of this line segment CM as B. Repeat again. According to rule number 11, in our drawing, we will get that AC times CB equals to QC times CM. AC equals to the square root of 5 units times CB. CB equals to 2x minus square root of 5 units. And it is equals to QC. QC is 5 times CM. CM equals to B according to our definition. So in conclusion, we found out that according to rule number 11, square root of 5 times 2x minus 5 equals to 5b. Here we divide this equation by square root of 5, and we get that 2x minus square root of 5 equals to 5b over square root of 5. Here we will add to this equation square root of 5, and we get that 2x equals to 5b over square root of 5 plus square root of 5. Okay, so we'll focus on this side of the equation, and we will multiply square root of 5 by square root of 5, and then we will divide it by square root of 5 in order to have a common factor with this expression. And we will get that 2x equals to, this will be equation number 1. We get that 2x equals to 5b over square root of 5 plus, we'll multiply square root of 5 by square root of 5, and then we divide it by square root of 5, so we change nothing. So actually, in conclusion, we found out that according to equation number 1, 2x equals to 5b plus square root of 5 times square root of 5 over square root of 5. So 5b plus square root of 5 times square root of 5 is 5 over square root of 5. So in conclusion, we found out that according to equation number 1, 2x equals to, here 2x equals to 5b plus 5 over square root of 5. Here we divide this equation by 2, and then we get that according to equation number 1, x equals to 5b plus 5 over 2 times square root of 5. Okay, and again, according to equation number 1, we found out that x is the radius of the semicircle, that is the variable that we are looking for. So in the next step, we will join points S and M together by a straight line. In the drawing we have peripheral angle MQS. This peripheral angle MQS equals to 90 degrees. And we have a new rule about peripheral angles that are equal to 90 degrees. This is actually rule number 5, so I'll write it down. Peripheral angle MQS equals to 90 degrees. According to rule number 5, any peripheral angle that is equal to 90 degrees must rest on the diameter of the circle. Here in the drawing we have peripheral angle MAN. This peripheral angle equals to 90 degrees. And therefore, according to this rule number 5, peripheral angle MAN must rest on the diameter of the circle. This peripheral angle MAN rests on MN, therefore MN must be the diameter of the circle. Okay, so we can actually implement rule number 5 in our drawing. Why? Because in our drawing we have peripheral angle MQS. This is peripheral angle MQS. It is equal to 90 degrees. Therefore, according to rule number 5, peripheral angle MQS must rest on the diameter of the circle. This peripheral angle MQS rests on MS. Therefore, according to rule number 5, MS must be the diameter of the circle. So I write it down according to rule, because of the fact that peripheral angle MQS equals to 90 degrees. According to rule number 5, peripheral angle MQS must rest on the diameter of the circle. Peripheral angle MQS rests on MS, therefore MS must be the diameter of the circle. The diameter of the circle equals to 2x. Okay, so therefore MS equals to 2x. MS equals to 2x. In the next step, I will copy the right triangle MQS in a new page, and we will implement on this right triangle MQS the Pythagoras theorem. Side QS equals to 5 units. What is the length of side QM? From the drawing it is very easy to see that QM in total equals to QC plus CM, that is to say QM equals to QC, that is 5, plus CM, that is B. So in total QM equals to 5 plus B. And the hypotenuse SM equals to 2x, it is the diameter of the circle. So actually, this is the right triangle QSM that I call it from the original drawing. According to the Pythagoras theorem, in this right triangle QSM, ms squared, that is the square of the hypotenuse, equals to qs squared plus qm squared. Again, ms squared equals to qs squared plus qm squared. ms is the diameter of the circle that is equal to 2x, therefore ms squared is 2x squared, and it is equals to qs squared. Qs is 5, therefore qs squared is 5 squared, that is 25, plus qm squared. Qm is 5 plus b, therefore qm squared is 5 plus b squared. So I actually found out that 2x squared equals to 25 plus 5 plus b squared. This is according to equation number 2. While according to equation number 1, we found out that x equals to 5b plus 5 over 2 times square root of 5. So we have the value of x in terms of b. Therefore, we can substitute x in this equation, equation number 2, by the value of x in this equation, equation number 1. So we'll do it now, and we'll get that in the equation number 1 we have 2x squared. So it will be 2 times x according to equation number 1 is 5b plus 5 over 2 times square root of 5. Okay, this expression is x. So it is 2x squared according to equation number 2, 2x squared equals to 25 plus 5 plus b squared. So, in this side of equation number 1, we have 2 in the numerator and 2 in the denominator, so 2 will get cancelled. So we cancel 2, we have here 5b plus 5 squared over square root of 5 squared. Square root of 5 squared is 5. And it is equal to, in the other side of the equation, we have 25 plus 5 plus b squared. So we will open the brackets on both sides of the equations, equation number 2, and we get that according to equation number 2, (5b plus 5 squared equals to 5b squared, that is 25b squared, plus 5 squared, that is 25, plus 2 times 5b is 10b, 10b times 5 is 50b. So 5b plus 5 squared in total it is equals to 25b squared plus 25 plus 15b. We have to divide it by 5, and it is equals to, in the other side of the equation we have 25 plus 5 plus b squared equals to 5 squared, that is 25, plus b squared, plus 2 times 5b is 10b. So in the other side of the equation we have 25 plus b squared plus 10b. In this side of the equation we have, this equation number 2, we have 25b squared over 5 is 5b squared, plus 25 over 5 is 5, plus 50b over 5 is 10b. And it is equals to, on the other side of the equation we have 25 plus 25 is 50, plus b squared plus 10b. So here we have on both sides of the equation 10b, therefore 10b we get cancelled. So after we cancel 10b, in this side of the equation number 2, we have 5b squared plus 5, that is equals to 50 plus b squared. So here we subtract b squared from this equation number 2, and we get that according to equation number 2, b squared plus b squared is 4b squared. So in this side of the equation we have 4b squared plus 5, that is equals to 50. Here we subtract 5 from this equation number 2, and we get that according to equation number 2, 4b squared equals to 50 minus 5 is 45. So 4b squared equals to 45. Here we divide this equation by 4, and finally we get that according to equation number 2, b squared equals to 45 over 4. So actually b squared, according to equation number 2, b squared equals to 45 is 9 times 5, so we substitute 45 by 9 times 5 over 4. Here we take a root out of this equation number 2, and finally we get that b equals to the square root of 9 times 5 over 4. So b equals to the square root of 9 is 3 over the square root of 4 is 2. So inside the root we left only with square root of 5. In conclusion, we found out that according to equation number 2, b equals to 3 times square root of 5 over 2. So we copy it again here in the new page. b equals to, according to equation number 2, b equals to 3 times square root of 5 over 2. This is according to equation number 2. While according to equation number 1, we have already found out that x equals to 5b plus 5 over 2 times square root of 5. Repeat again, according to equation number 2, we found out that b equals to 3 times square root of 5 over 2. Well, according to equation number 1, we found out that x equals to 5b plus 5 over 2 times square root of 5. Now, we'll substitute b in this equation number 1 by 3 times square root of 5 over 2 from equation number 2. And we get that according to equation number 1, x, it is the radius that we are looking for, the radius of the semicircle X, equals to 5b, and b is 3 times square root of 5 over 2 plus 5 over 2 times square root of 5. So actually found out that according to equation number 1, x equals to 5 times 3 is 15. So in total, this expression equals to 15 times square root of 5 over 2 plus 5 over 2 times square root of 5. So x equals to 15 times square root of 5 over 2. Here we multiply 5 by 2 and then we divide it by 2 in order to have a common factor with this expression. So it is plus 5 times 2, that is 10, over 10. All divided by 2 times square root of 5. So here we remove 2 times square root of 5 to the denominator here, and we get that x equals to 15 times square root of 5 plus 10 over 2 times 2 times square root of 5. So actually found out that x equals to 15 times square root of 5 plus 10 over, in the denominator we have 2 times 2, that is 4, so in total in the denominator we have 4 times square root of 5. In the next step we will substitute 10 by 2 times square root of 5 times square root of 5, and we get that according to equation number 1, x equals to 15 times square root of 5 plus 10, and 10 is 2 times square root of 5 times square root of 5 divided by 4 times square root of 5. Repeat again. We actually found out that x equals to 15 times square root of 5 plus 2 times square root of 5 times square root of 5 over 4 times square root of 5. In the next step, we take square root of 5 as a common factor from those two expressions, and we get that according to equation number 1, x equals to, so square root of 5 is taken out as a common factor. So what is left from 15 times square root of 5 after we took from it square root of 5 as a common factor? What is left is actually 15. And what is left from 2 times square root of 5 times square root of 5 after we took from it square root of 5 as a common factor? What is left is actually 2 times square root of 5, all divided by square root of 5 times 4. So here we have square root of 5 in the numerator and square root of 5 in the denominator, so square root of square root of 5 will get cancelled. And we actually found out that x equals to 15 plus 2 times square root of 5 over 4 units in terms of numbers. X, that is actually the radius of this semicircle, equals to 4.8680 units. And that is the answer to the question. So in the next step, I'll summarize the lecture. In this lecture, we found out the radius of this semicircle. In the drawing, we have a semicircle. We also know that line segment PA equals to 6 units in its length, and line segment PA is also tangent to the semicircle at point A. In addition, we know that line segment PQ equals to 4 units in its length, and this line segment PS cuts the semicircle at points Q and S. We also know that line segment QS equals to line segment QC. In addition, we know that this is angle PAB is equal to 90 degrees. This is angle SQC. It is also equals to 90 degrees in its size. Again, our mission is to find out the radius of this semicircle. So, first of all, I presented to you rule number 10 and implemented rule number 10 in our drawing. According to rule number 10, rule number 10 is true in any circle. Here, in this drawing, we have chord AB, that could be any chord, and we have from point P, we have tangent PT to this circle. So, according to rule number 10, the following equation is true in our drawing, in this drawing, that PT square equals to PA times PB. Again, PT square equals to PA times PB. We can actually implement rule number 10 in our drawing. Why? Because if we focus at point P, from point P we have tangent PA to this semicircle, and we also have from point P line segment PS that cuts the semicircle at point Q and S. For that reason, we can implement here rule number 10. According to rule number 10, we get here that PA square equals to PQ times PS. Okay, again. This equation is the implementation of rule number 10 in our drawing. PA square equals to PQ times PS. Okay. So, PA is 6, therefore PA square is 6 squared, that is 36. And it is equals to PQ. PQ is 4 times PS. PS, in total, PS equals to PQ plus QS. That is to say, PS equals to PQ, that is 4 plus QS. So, in total, PS equals to 4 plus QS. Here, PS equals to 4 plus QS. So, if we really found out that 46 equals to 4 times 4 plus QS. Here, we divided this equation by 4. And finally, we found out that 36 over 4 is 9, so 9 equals to 4 plus QS. Here we subtracted 4 from this equation. And finally we found out that QS equals to 9 minus 4, that is 5. So here QS equals to, here we have QS equals to 5 units in its length. Then we joined points P and C together by a straight line. And then we focused on the lower side of the straight line PS at point Q. At the lower side of PS at point Q, which angles we have? Here we have this angle that is equal to 90 degrees, plus the missing angle. In total, they must be equal to 180 degrees according to rule number 3. according to rule number 3, the sum of the angles on one side of a straight line is equal to 180 degrees. So here AB is a straight line. If you focus on the upper side of the straight line AB at point Q, here the sum of the angles must be equal to 180 degrees according to this rule number 3. So which angles we have at the upper side of AB at point Q? We have this angle alpha and this angle beta. So according to rule number 3, alpha plus beta must be equal to 180 degrees. We can actually implement rule number 3 in our drawing. One rule in our drawing, we have, if you focus on the lower side of the straight line PS at point Q, here the sum of the angles must be equal to 180 degrees. So which angles we have? At the lower side of PS at point Q, we have this angle that is equal to 90 degrees plus the missing angle. In total, they must be equal to 180 degrees according to rule number 3. Therefore, the missing angle here must be equal to 90 degrees. In order to complete the sum of the angles on the lower side of PS at point Q to 180 degrees, the missing angle here must be equal to 90 degrees. So if this angle equals to 90 degrees, it means the triangle PQC is the right triangle. So I copied the right triangle PQC in a new page and we implemented on this right triangle PQC the Pythagoras theorem. Okay. So actually this is the right triangle PQC that I copied from the original drawing. PQ equals to 4 units according to what is given us in the question. QC equals to 5 units according to what we have already found out. So in this right triangle here by PT is a version for Pythagoras theorem. According to the Pythagoras theorem, in this right triangle PQC, PC square equals to PQ square plus QC square. PC square equals to PQ square plus QC square. So PC square equals to PQ square. PQ is 4, therefore PQ square is 4 square, that is 16. Plus QC square. QC is 5, therefore QC square is 5 square, that is 25. So in total, PC square equals to 16 plus 25, that is 41. Again, PC square equals to 41. Then I copied the right triangle PAC in a new page and we implemented on this right triangle PAC the Pythagoras theorem. This is the right triangle PAC that I copied from the original drawing. Side PA equals to 6 units according to what is given us in the question. We define side AC as A. And we already found out that the square of the hypotenuse BC square equals to 41. So here by PT is a version for Pythagoras theorem. So in this right triangle PAC, according to the Pythagoras theorem, we get that PC square equals to PA square plus AC square. Or PA square plus AC square equals to PC square. PA is 6, therefore PA square is 6 square, that is 36, plus AC square. AC is A, therefore AC square is A square. And it must be equal to PC square, but we already found out that PC square equals to 41, therefore we can substitute PC square by 41. So in conclusion, we found out that 36 plus A square equals to 41. Here we subtract 36 from this equation, and finally we found out that A square equals to 41 minus 36 is 5. So A square equals to 5. Here we took a root out of this equation and finally found out that A equals to the square root of 5 units. Here A equals to the square root of 5 units. That is to say AC is equal to A is equal to the square root of 5 units. So we can write here that AC equals to A, or AC equals to the square root of 5 units. Okay, then we know that this is a semicircle. For that reason, AB must be the diameter of this semicircle. We defined the radius of this semicircle as x, therefore the diameter AB must be equal to 2x. Repeat again, AB must be the diameter of the semicircle. Why? Because of the fact that this is a semicircle, here AB must be the diameter of the semicircle. So we define the radius of the semicircle as x. Therefore, the diameter AB must be equal to 2x. Okay. Here the diameter AB must be equal to 2x. AB is 2x, AC is equal to 5. Therefore, BC must be equal to AB minus AC. Again, BC must, or CB must be equal to AB minus AC. So CB equals to AB, that is 2x, minus AC, that is equal to 5. So in total, CB equals to 2x minus equal to 5. Okay. Repeat again. The length of line segment CB is 2x minus equal to 5. Then we completed the semicircle to a circle. And we extended side QC by straight line until it touches the circle. We define the touching point of the extended side QC with this circle as M. Then I presented to you rule number 11, and we implemented rule number 11 in our drawing. Rule number 11 talks about two chords that intersect with each other inside the circle. So here, according to in the drawing, we have chord AB that intersects with chord CD at point O. Again, chord AB intersects with chord CD at point O. Point O is the intersection point of the two chords. So whenever you have two chords that intersect with each other inside the circle, then the following equation will be true. That AO times OB equals to CO times OD. Again, AO times OB equals to CO times OD. We can actually implement rule number 11 in our drawing. Why? Because in our drawing we have chord AB that intersects with chord QM at point C. Again, chord AB intersects with chord QM at point C. Repeat again. In our drawing we have chord AB intersects with chord QM at point C. Therefore, according to rule number 11, we get here that AC times CB equals to QC times CM. Again, AC times CB equals to QC times CM. Repeat again, according to rule number 11, we get that AC times CB equals to QC times CM. AC is equal to 5, CB is 2x minus equal to 5, and it must be equal to QC, that is 5, times CM, that is B. Here, CM, line segment CM equals to B units according to our definition. Again, line segment CM equals to B units in its length according to our definition. Okay, so in conclusion, according to equation number 1, we actually found out that square root of 5 times 2x minus square root of 5 equals to 5b. Here we divided this equation number 1 by square root of 5 and found out actually that 2x minus square root of 5 equals to 5b over square root of 5. Then we added to this equation number 1 square root of 5 and found out that 2x equals to 5b over square root of 5 plus square root of 5. Okay, so here, in order to have a common factor, we want that square root of 5 will have a common factor with this expression. Therefore, we multiplied square root of 5 by square root of 5 and then we divided by square root of 5. Okay. So here we have 2x that is equals to 5b over square root of 5 plus we multiplied square root of 5 by square root of 5, and then we divided by square root of 5, so we change nothing. So in the numerator of this side of the equation number 1, we have 5b plus square root of 5 times square root of 5 is 5. So in total, in the numerator here we have 5b plus 5 over square root of 5. So in conclusion, we found out that 2x equals to 5b plus 5 over square root of 5. Here 2x equals to 5b plus 5 over square root of 5. Here we divided this equation by 2, equation number 1 by 2. And finally, we found out that x equals to 5b plus 5 over 2 times square root of 5. Okay? Then we joined points S and M together by a straight line. So in the drawing we have peripheral angle MQS. This is peripheral angle MQS that is equal to 90 degrees in its size. And again, peripheral angle MQS equals to 90 degrees in its size. And we have here rule number 5 that talks about a peripheral angle that is equal to 90 degrees. According to rule number 5, any peripheral angle that is equal to 90 degrees must rest on the diameter of the circle. In the drawing we have peripheral angle MAN. The size of this peripheral angle MAN is 90 degrees. Therefore, according to this rule number 5, this peripheral angle MAN must rest on the diameter of the circle. Peripheral angle MAN rests on MN. Therefore, MN must be the diameter of the circle. We can actually implement rule number 5 in our drawing. Why? Because in our drawing we have peripheral angle MQS that is equal to 90 degrees. Therefore, according to rule number 5, this peripheral angle MQS must rest on the diameter of the circle. Peripheral angle MQS rests on MS, therefore MS must be the diameter of the circle according to rule number 5. Put again, because of the fact that peripheral angle MQS equals to 90 degrees, peripheral angle MQS must rest on the diameter of the circle. Peripheral angle MQS rests on SM, therefore SM or MS must be the diameter of the circle. And the diameter of the circle is 2x. It's twice as long as the radius. The radius is x, therefore the diameter SM must be equal to 2x. So SM equals to 2x. In the next step, I copied the right triangle MQS in a new page, and we implemented the Pythagoras theorem on this right triangle MQS. This is the right triangle QMS or SQM, it doesn't matter. The length of side QS is 5 units. QM equals in total to 5 plus B. You can see it here. That QM in total it is equals to 5 plus B. And SM is the diameter of the circle that is equal to 2x. The hypotenuse SM is the diameter of the circle that is equal to 2x. Here by PT is a relation from Pythagoras theorem. According to the Pythagoras theorem, in this right triangle SQM, SM square equals to SQ square plus QM square. Again, SM square equals to SQ square plus MQ square. SM is 2x, therefore SM square is 2x square, and it is equals to QS square. QS is 5, therefore QS square is 5 square, that's 25, plus QM square. QM is 5 plus B, therefore QM square is 5 plus B square. So, in conclusion, found out that according to equation number 2, 2x square equals to 25 plus 5 plus 5b square. Again, 2x square, according to equation number 2, 2x square equals to 25 plus 5 plus b square. This is according to equation number 2, but according to equation number 1, we have already found out that x equals to 5b plus 5 over 2 times root of 5. Therefore, we can actually substitute x in this equation number 2, by 5b plus 5 over 2 times root of 5. Okay, so actually we did it, and we found out that according to equation number 2, we have 2x squared. So it is 2 times x, and x, according to this equation number 1 is 5b plus 5 over 2 times root of 5 squared, because it is 2x squared. And it is equal to 25 plus 5 plus b squared. Okay, so here we have 2 in the numerator and 2 in the denominator, so 2 will get cancelled. After we cancel 2, we have here 5b plus 5 squared over square root of 5 squared. Square root of 5 squared is 5. So in total, in this side of the equation, after we cancel 2, we left only with 5b plus 5 squared over 5, and it is equals to 25 plus 5b, 25 plus 5 plus b squared. So in the next step, we open the brackets on both sides of this equation number 2. So here we have 5b plus 5 squared. 5b plus 5 squared equals to 5b squared, that is 25b squared, plus 5 squared, that is 25, plus 2 times 5b is 10b, 10b times 5 is 50b. So in total, in this side of the equation, we have 25b squared plus 25 plus 50b, all divided by 5. In the other side of the equation, we have 25 plus 5b squared. So we open the brackets here. 5 plus b squared equals to 5 squared, that is 25, plus b squared, plus 2 times 5 is 10, so it is plus 2 times 5b, that is actually 10b. So in total, we have this out of the equation, 25 plus 25 plus b squared plus 10b. Here 25b squared over 5 is 5b squared, 25 over 5 is 5, and 50b over 5 is 10b. In the other side of the equation, we have 25 plus 25 is 50, plus b squared plus 10b. So here we have 10b on both sides of the equation, so 10b will get cancelled. After we cancel 10b, in this side of the equation we left only with 5b plus 5b squared plus 5. In the other side of the equation, we left only with 50 plus b squared. So in total, according to equation number 2, we found out actually that 5b squared plus 5 equals to 50 plus b squared. Here we subtracted b squared from this equation number 2, and finally found out that 5b squared minus b squared is 4b squared, so it is 4b squared plus 5, this is equal to 50. Here we subtracted 5 from this equation, and found out that 4b squared equals to 50 minus 5, that is 45. So according to equation number 2, 4b squared equals to 45. Here we divided this equation number 2 by 4, and finally found out that b squared equals to 45 over 4. So b squared equals to 45. 45 is 9 times 5, so we substitute 45 by 9 times 5 over 4. Then we took out of this equation number 2, and finally found out that b equals to the square root of 9 times 5 over 4. The square root of 9 is 3, over the square root of 4 is 2. So inside the root we left only with 5. In conclusion, found out that according to equation number 2, b equals to 3 times square root of 5 over 2. And again, actually found out that according to equation number 2, b equals to 3 times square root of 5 over 2, while according to equation number 1, we have found out that x equals to 5b plus 5 over 2 times square root of 5. Now we can substitute b in this equation number 2, by 3 times square root of 5 over 2. We did it, and found out actually that x equals to 5b. and b is 3 times square root of 5 over 2 plus 5 over 2 times square root of 5. Only to equation number 1. So here we have 5 times 3 is 15. So in total this expression equals to 15 times square root of 5 over 2. Here this is 15 times square root of 5 over 2 plus 5 over 2 times square root of 5. So here we multiplied 5 by 2 and then we divided by 2 in order to work out a factor with this expression. So here we get that x equals to 15 times square root of 5 over 2 plus 5 times 2 is 10 over 2. We multiplied by 2 and then we divided by 2, so we change nothing. So in conclusion found out that according to equation number 1, x equals to 15 times square root of 5 plus 10 over 2 over 2 times square root of 5. Then we moved 2 times square root of 5 to the denominator here. And therefore in conclusion found out that x equals to 15 times square root of 5 plus 10 over 2 times square root of 5. 2 times 2 is 4, so in total in the denominator we left with 4 times square root of 5. In the numerator we have 15 times square root of 5 plus 10. Here we substitute 10 by 2 times square root of 5 times square root of 5. And we found out that x equals to 15 times square root of 5 plus 10. And 10 is 2 times square root of 5 times square root of 5, all divided by 4 times square root of 5. Then we took square root of 5 as a common factor from those two expressions. So x equals to square root of 5 is taken out as a common factor. What is left from 15 times square root of 5, we took from it square root of 5 as a common factor. What is left is actually 15. What is left from 2 times square root of 5 times square root of 5, after we took from it square root of 5 as a common factor, what is left is actually 2 times square root of 5, all divided by square root of 5 times 4. We have square root of 5 in the numerator and square root of 5 in the denominator, so square root of 5 will get cancelled. And we finally found out that x equals to 15 plus 2 times square root of 5 over 4 units, or x, that is actually the length of the radius of the semicircle, equals to, in terms of numbers, it is equals to 4.8680 units. I'll repeat again. The radius of this semicircle, that is x according to our definition, is equals to either 15 plus 2 times square root of 5 over 4 units, or in terms of numbers, the radius x of this semicircle equals to 4.8680 units in its length. Okay, thank you very much.